Hi everyone. Starting this day slightly earlier than most days because I've realized that my footage yesterday is completely useless. Actually, if you see it on my screen now, for some reason the entire footage is just the OBS thing open. So I hopefully will not manage to do that again. Don't really know how it happened, but I mean, things looked reasonable, so hoping for the best this time. Also, a bit of shameless self promotion. I have a Substack where I actually post my thoughts for the days. So if you're more inclined to read text rather than watch these videos, or both, it might be something reasonable to check out. I go over both, my thoughts for the day as well as some solving strategies, and I try to highlight one or two cool things when I can. In last year's version, for example, I think I mentioned some cool Python tools like NetworkX, as well as some like cool GitHub stuff like AOC tiles. The only thing recently that I found pretty interesting was regex 101, which is a pretty nice plug and play tool if you're not too familiar with regular expressions. It'll both take in a regular expression and show you exactly how the matching groups work and why things match the way they do. Oh, this is a very short input today. Interesting. All the stones simultaneously change. If it's 0, it becomes 1, and if it has an even number of digits, splits. Otherwise, it's multiplied by 20, 24. How will the stones evolve? Okay, got it. So we have these stones. There's only one line, right? Yep. Okay, cool. So we don't need this. Just have this. Is this a single space? Yeah, it's one space, and the numbers are in the million, so they're easily small enough to fit within an int. But let's use a log just in case. Also, I'm already a bit concerned because it seems to roughly double. Oh, 55,000 is not too big though, so I'm going to stick with using longs for now. Although I suspect for part 2 I may end up needing something else. But I don't want to over-optimize for step 2 before I see it. I think that's actually often a mistake because very often, it doesn't actually do what you think it does. Cool. So, what was it? 25? So we want to have... Actually, let's just do a helper method here. Also, this is a Tuesday problem, so I expect it to be not too bad. At least part 1 so far doesn't seem too bad. But you never know, part 2 might significantly ramp up the difficulty. Goodness, can't even spell. How do you know? Okay, wait, we're gonna do something kind of whack, but we're gonna convert back into a string. That way we can do the length and to see whether it's equal or not. Yeah, so if it's equal, oops, the wrong direction. So if the string length is even, we should split it in half. Also, apologies, apparently I have some YouTube thing playing in the background. I think it's probably myself. Not the greatest, so my bad there. We know the length is divisible by 2. Now, do we add 1 to this? I think so. Oh, I don't know. Okay, I'm going to try adding 1 to this. I don't actually know if that's right. But we shall see. I should learn the shortcut for executing. Huh? What's going on here? For input string. It's probably not with the +1 then. Let's try removing the +1, see how it goes. That's an answer. Nice. Yeah, that's the problem. I have a feeling this is going to go very poorly, but we shall see. So in 25 it became 173,000. So if we do the rough math, cubed, yes, the number is in the E15 range. That is not really doable, huh? Okay, new plan. We don't go to 75. Let's try 26, 24, 25, and 26 and see the similarities. 293, 299. It was 193, 899. And let's do 24. We'll get us 125396. Well, we have a rough ratio here. 293, 299 divided by 193, 899 is 1.512. Okay, and then divided by 125396. Well, oh, that's not good. The ratio isn't that close to being the same. Okay, well, we can still try something else, right? We can... I guess my first thought was, what if we represent it with a map? I wonder how many of the elements are the same. Let's actually do a quick check of that. Stones dot... How do I do this? Oh yeah, set long, no repeats, equals new hash set stones, and then let's do no repeats dot size, just to see how big it is. Does the number of unique elements also grow? Oh no, the number of unique elements is actually very tiny. Interesting. What if I increase this to like 35? Are there a lot of new unique elements? Yeah, there are. That is quite unfortunate, huh? How do I mean, 35 took a while, so clearly 75 is not brute forceable. wonder if there's a pattern here, but I don't know quite how to determine the pattern, right? I mean, one thing we could do is just store a map. Right, okay. Let's start there. That'll at least speed it up. Right, because we don't actually need to check through the thing every time. So we start with a hash map, right? Oh, this should be inside the thing, not outside. And then, oh, longs could get really big. Yeah, I don't think I can store every long. Okay, what if I also just print no repeats? See what kind, because I mean, not every element is reachable, I think, using this system. So let's see what elements are reachable and which ones are not. Oh, I shouldn't have done such a big, okay. 0. Right. The thousands and the, oh goodness, these numbers get ginormous. Yeah, look at that. That's 1,000 million billion, 300 billion. Yikes. Huh. Okay, well that's quite unfortunate. Because I can't just store a map. I mean, the map would be in the trillions, maybe quadrillions. I don't think I even have the memory to store a map that big. So what can I do? Well, at the very least, I think I can use this map at least to some capacity, right? Because what I can do is use a map instead. So for long stone in stones, map dot, oh goodness, I gotta do this thing again. So long num equals map dot get or default stone. Then we do map dot put stone num plus 1. Right, so now we can do this with a map. Should be able to copy most of this logic. So for each map, sorry, for each key, we want to basically do, where is it? Do this. Okay, so get the long and then put in for 1. Otherwise, instead of 1, it is key times 2024. Oh, and we should be doing map dot get key. Right. here. Oh, we gotta do this twice, but that's fine. So, nope, way off on the number of, there we go. Something like that, I think. And then we basically just want to do for, we just care about the values, right? So we can just do answer plus equals val, return answer plus. So this should hopefully be faster. Not at all. In fact, it doesn't even work. Huh. Why does this not work? One cycle map. Invocation target error. Huh? Oh, concurrent modification. Ah, right. We never used the new stones. Oops. That would make a lot of sense. We are indeed concurrently modifying. That doesn't seem like the right number. Yeah, those numbers are not remotely similar. What in the world? Yeah, what's going on here? These numbers should be identical. Oh, are all the elements unique at the beginning? Okay, that's quite good. That doesn't really explain why it's so far off. So we get, oh, is it because it's not 0L? This doesn't really make much sense to me. These should really give the same results, right? Like, what's the difference here? Here, let's change both of these to 1. Oh, dang, they're the same for 1. Okay, let's try 2. Yeah, okay, they've diverged. So now let's do quick print here and a quick print here. See what the difference is. No, we're not in debugger mode. Dang that. Okay, so we have 2 1s. Oh, this one we have 1 1. That's already different. Oh, this shouldn't be a map bucket. This should be new stone bucket. That's why it's all weird. Yep. Okay. Let's get rid of some of these lines. Go back up to 25. The reason I'm removing the lines is just so the print statements don't go crazy. Alright. So 25 is fine. Is 35 fine? Yep, 35 is still pretty instant. What about 45? Yeah, pretty instant. What about 55? What is long.max? Thousand, million, billion, trillion, quadrillion. Okay, so E3 e6, e9, e12, e15, oh, long is actually big enough. Oh my goodness, and this is so fast. Wow, okay, well, I don't know if this is right, but if it is, that's quite nice. It is. Good stuff. Yeah, literally was just changing to a long. Wow, I did not get it very fast compared to other people, but yeah. Hopefully you are actually able to watch this video, and I will see you tomorrow.